For our next example, we're going to be going back to positive infinity. We're going to evaluate the limit as x approaches infinity of x squared over the square root of x cubed plus 1. So the bottom looks a little weird here because there's a square root. That's okay. We can write this as a power eventually, and we can solve this just like any fraction. Okay, so let's go ahead and do that. Step 1 is to determine the largest power in the denominator. So well, the thing is, we have to include this square root as part of the x cubed. I mean, that is the biggest power, x cubed, but there's a square root over top of it, so we have to include that. So we're ignoring the 1 because it's not the largest power. We're going to take the largest power in the radical and write it as the square root of x cubed. So for example, if this was x squared, the largest power would be the square root of x squared, which is just x, right? So that's how you do that. Step 2, to divide the numerator and denominator by this power. So and this is why, right? Because, you know, I can't divide x cubed into that unless there's a radical there. So that's why we do that. So top is going to be x squared over x cubed. Bottom is going to be the square root of x cubed plus 1, all divided by the square root of x cubed. Step 3 is to simplify. So I can write the square root of x cubed as x to the 3/2. For the top, for the bottom, I can keep it that way because then I can just distribute the x cubed there. So we get x squared over x to the 3/2 all divided by square root of x cubed plus 1 over square root of x cubed. I'm going to convert this x squared as x to the 4/2. That way I can subtract these. So x to the 4/2 over x to the 3/2 is x to the 1/2. And like I said, for the bottom, I can now distribute this x cubed into both of those terms, which is what I'm going to do now. I'm actually just going to make it one big square root, right? Because it's a square root over a square root, so I can just make it one big square root. So and then I can distribute the x cubed into both of these terms. So it's the square root of x cubed over x cubed plus 1 over x cubed. Now, you know, x cubed over x cubed is 1, and then that just remains itself. So now we have this. So that completes step 3, which is just to simplify down to those individual terms after you've divided by the largest power. Alright, so step 4, we can now evaluate the individual limits. So I'm going to be plugging in infinity everywhere there's an x. So the top I have infinity to the 1/2, and the bottom I have the square root of 1 plus 1 over infinity cubed. So let's look at the top here, infinity to the 1/2 power. If we go back to the rules for limits at infinity that we learned, we know that the limit as x approaches infinity for x to the n for any n, including that's bigger than 0, including n equals 1/2, it's going to approach infinity. Okay, even though you're taking the square root of it, you know, it's still going to approach infinity. So for example, like if I plug in 1 trillion and I take the square root of that, it's still going to be really big, right? And the bigger I make x, the bigger y gets. So that's going to be infinity. And the bottom won't really matter. Well, I guess if it was undefined, it would matter. Okay, so the bottom we have 1 over infinity cubed. Again, this is the rule for 1 over x to the n. As long as n is a positive number, that's going to approach 0 because we're taking 1 and dividing by a huge number. That's, again, think of it this. Take a pizza, divide it into infinitely many pieces. Nobody gets anything, right? It becomes 0. Okay, so we have infinity over the square root of 1. So it's going to be infinity over 1. So for step 5, we're going to evaluate the limit now. Infinity divided by 1, yes, that's actually infinity. Okay, just again, take 1 trillion. That's a really big number. Divide by 1. You're still going to get 1 trillion back. Okay. So final answer: limit as x approaches infinity of x to the 1/2 over the square root of 1 plus 1 over x cubed is equal to infinity. Oh, sorry, I should probably write the original one out, right? The original question was limit as x approaches infinity of x squared over the square root of x cubed plus 1 is equal to infinity. Let's now take a look at the graph. So here is our graph. Let's zoom out here a little bit. We have x squared over the square root of x cubed plus 1. Now, as I take my x and I make it bigger and bigger and bigger, what is happening to my y value? It's also going to get bigger and bigger and bigger. It kind of looks like a check mark, actually. Y is going to increase without bounds, so therefore my limit as x approaches infinity of x squared over the square root of x cubed plus 1 is going to be equal to infinity. Alright folks, that's it for this example. If you have any other questions about it, let me know.